If you were to open up Google Maps and look at a satellite view, you'll actually notice kind of these dry spots that occur in certain spots, kind of these horizontal bands, one just north of the equator and one just south of the equator. And so this actually has to do with an effect that happens at certain latitudes. And we're going to talk about that now, why those deserts are there. So if you don't have an understanding of latitude, you might want to go look that up real quick. But here is our equator, and then latitude is the degree away you are from the equator. So here's 30 degrees away, 60 degrees away, 90 degrees away. And I have another video that talks about how, so 0 degrees is the equator, and then you go up to 90 degrees like that. So that's the degrees that we're actually measuring. And you would do the same thing. These are also the north. You would do the same thing to the south, the southern hemisphere. And what happens here is we have these circulation cells of air that are circulating in the atmosphere right above Earth's surface. So I'm going to go ahead and draw those in now, and then we'll talk about them. Okay, so I drew these cells over, and of course this would extend all the way around the Earth's surface. I'm just drawing kind of a cross section through so you can see what the air is doing. And what we'll notice is that at the equator, the air is rising, and then it travels north to about 30 degrees, and then it sinks. This next cell, the air actually travels over the surface towards 60 degrees, rises up at 60 degrees, travels back south, and then sinks at 30 degrees. But what's really important here is that you get sinking air right here, rising air right here. And with this cell at the top, same thing happens. You get sinking air at 90 degrees. So let's make that notation. Okay, so you can see how it alternates. Rising, sinking, rising, sinking. All right, so let's think about what happens when air either sinks or rises to temperature. So the higher you go up in the atmosphere, generally speaking, the cooler it's going to get. And then as you sink back toward the Earth's surface, it's going to get warmer. So we're going to go ahead and write those words on there to solidify that. Okay, so now our alternation goes cooling air, warming air, cooling air, warming air at 0, 30, 60, and 90 degrees. In one of my other videos on the rain shadow effect, I talked about the effect of the ability of air to hold moisture based on temperature. So if you don't understand that concept, go to my other rain shadow effect video. I'll link that in the comment, and then you can watch the first part of that video. But basically what happens is when air cools down, it loses all of its water. When it warms up, it holds onto its water. So here at the equator, it's going to be losing all of its water because the air cools down. Here at 30 degrees, because it's warming up, it's going to hold on to that water and be nice and dry. Okay, so here at 30 degrees, it's going to be dry. And then at our equator, again, because the air is cooling, it's going to tend to be wet. And we would see the same thing in the other two bands, so I'll write that now. Okay, so what we actually see is the air tends to be very dry at 30 degrees and also 90 degrees. And so if you were to look at that map that I talked about, Google Maps, one of the bands that you see of kind of dryness is at 30 degrees north and also 30 degrees south. The other band that you don't really see it, but it's there, is the North and South Pole. So our pole is actually a desert, and that's just because it really does get very little moisture, and it's because relatively the air is warming up. It goes from very cold to kind of cold, and it holds on to all that moisture. And so that's why we get our dry bands at the poles for our polar deserts. And then we get our dry band right at 30 degrees. And that happens in the north and southern hemisphere.